Hello everyone, my name is Ali Reza Arfanian and welcome to my presentation entitled Optimizing QoE and Latency of Live Video Streaming using Edge Computing and Network Intelligence. In this presentation, I'll introduce the live streaming challenge, then talk about the defined research question, methodology, contribution, future work, publication, and finally a schedule on work. After broad literature review, following challenges were highlighted in live streaming context. First, end-to-end latency, that is essential QoE parameter that's sometimes conflicting with the other QoE parameters. The next one is that the current transmission protocols like TCP are not suitable for the live streaming due to long RTT and slow start congestion control. The third one is the scalability, especially for the popular events with huge number of requests. And finally, queue fairness among users with shared bottleneck. Taking into account the mentioned challenge, we come up with the following research question. First, how to deliver a smooth video streaming with high quality to increase the user's QoE by using edge computing and network intelligence. In this direction, we leverage edge computing capabilities and in network intelligence like NFV to run some tasks like transcoding as VNF somewhere in network closer to clients. The next one is how to decrease the end-to-end latency by leveraging in network intelligence and various transmission protocols. By using new networking paradigms like SDN, we can detect the network characteristic of each part of live streaming from the origin servers to the end users and utilize suitable transmission protocol for each part. The third one, how can new paradigms like NFV, and edge computing help the scalability issue while meet the expected QoE by clients? Utilizing these paradigms can provide the ability for running some tasks like multicasting with better performance than conventional method. And the last one, how to increase QoE fairness by using information at the edge. To cover this research question, we are going to use available information at the edge like network conditions to propose an edge-assisted adaptation approach for enhancing QoE fairness. Quantitative method is selected as a research methodology and a spiral model for implementation model. Thesis goal is to address define research question by proposing comprehensive architecture to decrease end-to-end latency and increase client's QoE and scalability by employing information and capability at the edge, leveraging state-of-the-art in network intelligence paradigms like SDN and NFV. We evaluate the proposed approach through the objective parameters by implementation, emulation, and simulation. First step and in direction of the research question 1 and 3, we propose a framework named OSCAR by leveraging SDN, NFV, and multicast ABR paradigm. The main idea of OSCAR is to employ SDN multicast approach to transmit video stream only in the highest quality desired by the clients from the origin server to some virtual transcoder in the network closer to the end user. The other requested quality by clients are prepared by transcoding from the highest quality. Mitigate the introduced delay and cost by transcoding and address the research question 1 to 3. We propose a novel transcoding method called lightweight transcoding at the edge or LWT. The idea of LWT is to extract some metadata during the encoding process and reuse them in transcoding process to reduce the transcoding time and computational cost. The implementation results showed that LWT can reduce the transcoding time up to 90%. Also, the size of extracted metadata are relatively small compared with the video representation itself. Moreover, the experimental evaluation show up to 60% cost saving compared with the state-of-the-art approach. For the future work and to address this question 1 to 3, we plan to extend the proposal WT model by considering new parameters. Also, in direction of research question 1 to 3, we are going to study end-to-end latency reduction by employing an appropriate transmission protocol. And finally, we will study employing available information and capability at the edge server to address this question 4. In this slide, you can see some of our publications in the topic. In the last slide, my schedule and work plan is presented, and that's all from me, and thank you for your attention.